So this is the 2021 Gauss grade 8, problem 24. So the problem is Jonas builds a large n by n by n cube using 1 by 1 cubes, each having the net shown. So what is the smallest value for n for which the sum of exterior faces of the n by m cube can be greater than 1500? So A is 9, B is 11, C 12, D 13, and E 16. So our solution. So the maximum value of a corner cube is 1. You can see it's 2, -1, and 0. So these three cubes right here. The maximum value of an edge cube is 2. So 2 and 0, the sum of 2 and 0. So these two cubes right here. And the maximum value of a center cube is 2, and it is just 2 since it only shows one side of the cube. So there are 8 corner cubes in total on the giant cube. There are 12 total rows with edge cubes since there are 12 edges on a cube, and there are 6 faces with center cubes since there are 6 faces on a cube. So we get the sum of the corner cubes by doing 8 times 1, since the maximum value of a corner cube is 1, and there are 8 of them, so we do 8 times 1. And edge cubes, 2 times 12 times n minus 2, so we do 2 since the maximum value of an edge cube is 2, and since there are 12 of them, 12 edges with them, we do 12, and n minus 2 because on each edge there are as many as n is, but then you subtract 2 because there are 2 corner cubes on the outside, so we subtract 2 right there. And then for the center cube, we do 6 times 2, so 6 since there are 6 faces containing corner center cubes. 2 because the maximum value is 2, and n minus 2 times n minus 2 because there are n minus 2 by n minus 2 cubes, since again the edge cubes are on the outsides. So merging the expressions together, we get 8 times 1 plus 2 times 12 times n minus 2 plus 6 times 2 times n minus 2 times n minus 2, which is 8 plus 2 times 12n minus 24 plus 12 times n minus 2 squared. And 8 plus 24n, that's 8 plus 24n minus 48 plus 12 times n squared minus 4n plus 4. And then that's 8 plus 24n minus 48 plus 12n squared minus 48n plus 48 if we distribute the 12 in. And then we get 8 plus 24n minus 48 plus, yeah, we get, and then we get 12, merging the terms, the 48s cancel each other, and we get 12n squared minus 24n plus 8. So now n can be found through trial and error by plugging in each of the multiple choices from least to greatest until the result is greater than 750, since we divided by 2. Sorry, until the result is greater than 1500. There's a little typo there. So plug in choice A9. We get 12 times 9 squared minus 24 times 9 plus 8. That's 756. That is less than 1500. When we plug in choice B, which is 11, we get 1,196, which is also less than 1,500. If we plug in C, we get 1,448, which is close to 1,500, but not greater than 1,500. And once we plug in D, 13, we get 1,724, which is greater than 1,500. And we do not need to plug in the last choice because 13 is already greater and the last choice will only get bigger. And so 13 is the smallest n value, which with its sum greater than 1,500. All right, so that is the end of the first presentation.
Wait, I have a question.
Yeah.
You got to slide 2?
This one?
Yeah.
Yeah.
It says that we have 8 corner cubes, but if it's a 1 by 1 by 1 cube, isn't it just gonna be a 1 block?
Oh no. What it's using 1 by 1 by 1 cubes to build an n by n by n cube. So you can see it's basically a Rubik's cube. You can see right here. These are all. This is a big cube, right? You see here. This is a big cube, but it's made of little 1 by 1 by 1 cubes. So that's what the 1 by 1 by 1 cubes mean.
Oh, Kyler?
Yeah.
So when you say the maximum value of a center cube is 2, when you're talking about center cubes, are you talking about how's it like 2? So,
because you can see the net.
Oh yeah, the net.
Yeah, you can see the net. Since the center cube only exposes one face, we can choose the greatest, the face with the greatest value on it to face outwards.
Oh.
We can, so yeah, we can make it 2.
Okay, I know now.
Yeah, nice. Okay, no more questions? Okay, then I'll move on to the next one.